The gypsy moth is a serious threat to oak and aspen trees. A state agriculture department places traps throughout the state to detect the moths. When traps are checked periodically, the mean number of moths trapped is only 0.5. But some traps have several moths. The distribution of moth counts is finite and strongly skewed with standard deviation 0.7. What are the mean and standard deviation of the average number of moths in 50 traps? So what is the question they are asking? They are asking average number of moths. Okay, the mean and standard deviation of the average number of moths. Understand that? It is not asking number of moths, right? Because we know already number of moths. Okay, I say X is the number of moths, right? So then X, mu of X equal, it is given 0.5, right? It is 0.5. And standard deviation of X equal 0.7. Those are the information we have now, right? And also we know here this talk about n, the sample size, right? Now they are asking again, read the problem, mean and standard deviation of the average number of moths. So I explained last time this concept. Now we need to find the mean of x bar. How do we find the mean of x bar? It is the same as x, right? That is the same as x, 0.5. But standard deviation of x bar, it is what? Sigma x over n square root. So that is the standard deviation of x bar, right? Right. So then, how do we find this? Sigma x, we know it is 0.7 divided by n equal 50. So square root of 50, right? So then this one, 0.7 divided by square root of 50, 0.099. If my answers, if I do any mistake, please let me know, okay? So this is the standard deviation of x bar. Understood this? Right. Then, what is the variance of x bar? So variance of x bar equal 0.099 power 2. Whatever it is, you can do that, right? 0.099 to power 2. Understood that?
What is that? What is the power 2?
This one?
Yes. Like what is that?
Is the variance.
Okay.
This is a variance, okay? Sigma square is a variance, right? So then, use the central limit theorem to find the probability that the average number of moths in 50 traps is greater than 0.6. Okay, why we need to use the central limit theorem? You see here is strongly skewed. Okay, finite and strongly skewed. Strongly skewed, that means it is not normal. To use the z table, it should be normal, right? Strongly skewed means that is not normal. How do we know that? Your normal distribution is symmetry, bell shape and symmetry. Okay, but it say use the central limit theorem. Yeah, that's the central limit theorem mean. When we have enough sample size, we can use a normal distribution, right? Even it is not normal, right? Use the central limit theorem to find the probability that the average number of moths greater than 0.6. It again, read the problem, it's asking average number of moths, not number of moths, right? Okay, average number of moths mean x bar it is greater than 0.6. That's they are asking. So then you know this is greater than part. Therefore we write down 1 minus probability x bar less than or equal 0.6. Right. Now we need to convert to the z value. How do we convert to the z value? Yes, exactly. Let me explain. If we had, I will write down over here, z, if we had x, sorry, it is x, okay? That is not x bar. X minus mu, here actually that should be mu x divided by sigma x. So this is the z value for the x, right? But here you see we have x, but now we have x bar. Therefore z equal x bar minus mu x bar minus sigma x bar. We already know these values, but let me write down this way too. X bar minus mu x bar is mu x, right? Which is we use mu, right? So then mu divided by sigma x bar means sigma over root n. Understood that? But we know these values, therefore we can use. Right. 1 minus probability x bar less than or equal 0.6 minus mu x bar is 0.5 divided by sigma over root 10. We already know this one is the sigma x bar. This is the sigma x bar, which is sigma over root 10, that is 0.099. So this one. Actually, when you convert to z, then this is not x bar anymore. Then what is that? That is z. Understand? So it is not x bar anymore, right? Well, we convert both sides actually to the z. Okay? So this is x bar. Actually we didn't write, but that should be x bar minus mu x bar divided by sigma x bar. So that is the z now. Okay? That's why I write down over z. We have no numbers, right? Right. Then 1 minus probability z less than or equal. So what is this number? It is 1.01, right? 1.01. Now what to do? Now we need to use the z table, right? It is a chapter 3 again. Yes, 1.01, go to the z table. 1.01, you see 1.0 here and 1.01 is here. You see that 1.01, right? So therefore we can write this equal what was that? 0.8438. Is it right? 0.8438. Yes, 0.8438. Then 10, 8, 2, 96, 945, 981. So this is the probability x bar greater than 0.6. So you can leave this way if they are asking percentage, or you can leave this way as well. This one, 15%, 0.62, right? 15.62%. Understood that? Everybody? Researchers surveyed 500 American anabolic androgenic steroid users ranging in age from 16 to 62 and found that 98.8% of them were male. The proportion of all Americans between the age of 16 and 62 who are male is 50%. the median age at which those surveyed began using steroid was 22. Is each of the bold-faced numbers a parameter or a statistic? Right. You know what the parameters are. Parameters are coming from sample, right? Yes? Parameters are coming from what? Not sample. Population. And statistics are from sample. Understood that? Right. So then tell me 98.8. What is this? It is a statistic or some parameter? What is that?
Statistic.
It is statistic. Why? It is coming from the sample 500 survey, right? It's a research survey, 500 American, 500 people, right? That is a sample. It says, see, age from 16 and found that 98.8. Understood that? Therefore, it is statistic. And how about 50%? Yes, okay?
Parameter.
Parameter. Why? It says all Americans. That is the population. All Americans. Think about this way. I am going to do some research about some type of trees in Alabama. Then what is my population? All trees in Alabama. Understood that? Okay. So that's the way he actually, this is parameter population, therefore this is parameter. Okay, next one. 22. What is the 22? It is from
That's the median.
Jessica. Yeah, it is from statistic. Why? It is from sample, right? It is from sample, and therefore statistic. Understood that? So you should know how to recognize those for the test. Okay. Joan makes a measurement in a chemistry laboratory and records the result in his lab report. Suppose that if Joan makes this measurement repeatedly, the standard deviation of his measurements will be sigma equal 10 milligrams. Joan repeats the measurement 3 times and records the mean x bar of his 3 measurements. Understood that? Right. What is the standard deviation of Joan's mean result? Okay, how do we find the standard deviation of this Joan's mean result? Yes, let me write the information we have. We have, suppose I say x, we have the standard deviation. It is normal distribution? No, right? It doesn't say that. Right, therefore sigma x equal 10. Right, now they are asking, and you want to repeat the measurement 3 times. What is the 3 times? What is the 3 times?
Procedure or whatever.
It means what is the notation we use? It is a sample what? 3 times. Sample size. It is simple n. Right? It is simple n. We know n equal 3. Right. What is the standard deviation of Joan's mean result? Standard deviation of mean this. Right. So what is this? This equal sigma x divided by root n. So sigma x equal 10 divided by root 3. So this should be 5.774. 5.774. So that is the standard deviation of the mean. Okay, standard deviation of the mean. Understood everybody? Right. So next one. How many times must Joan repeat the measurement to reduce the standard deviation of x bar to 3 milligrams. And now we need to reduce standard deviation of x bar to 3. This one 3. Okay, that is a 3, right? So then asking how many times we need to do this experiment. That means they are asking what? N, right? But sigma we know, sigma x, we know that sigma x equal 10. Right. Now how do we find the n? You know sigma x bar, it means standard deviation of the mean equal sigma x over root n. So sigma x bar is 3, sigma x is 10, we don't know n is unknown. So we have only one unknown, right? So we can find this n. How do we do that? Root n equal 10 divided by 3, that means 3.933, right? 333, right? Repeating. Understood that? So then you see root n equal 3.33. Then how do we find the n? Get the second power of the both sides. So then n equal 3.33 the power 2, that is 11.1111. Can we leave this n equal 11.11? Can we leave this that way? Yes or no? No. Why? Reason is, what is the n? N is the sample size. If I ask you to pick something, suppose trees, okay, I say, okay, can you pick 11.11 trees? No. Sample size must be a whole number, right? So therefore, if you have decimal, actually what you have to do, just you round up always, okay? Therefore n equal 12. So that is the answer. Don't keep decimals for the n sample size, and also always we should round up. Okay, it doesn't matter number, what the number is, always up. Okay, right. Any questions? No. And this one. Read the problem. A brake pad manufacturer claims its brake pads will last for 38,000 miles on average. Assume that the lifespans of the brake pads are normally distributed. Okay, I say this x is normally distributed. Now we need to find the mu and sigma. First analysis indicate that the population standard deviation is 5,000, and actually here what? This is the average, right? Therefore, we can say 38,000, that is the mean, and 5,000 is the standard deviation. If we write in other way, sigma x equal 38,000, and sorry, it is not sigma x, it is what? It is mu x, and sigma x equal 5,000, right? In the then brake pad using, okay, you work for a consumer protection agency and you are testing this manufacturer's brake pad using a random sample of 30. Then what is the 30? 30 is n equal 30, that is the random sample, right? In your test, the mean lifespan of the brake pads you sample is 35,700 miles. Would it be unusual to have an individual brake pad last for this? Okay. Would it be unusual to have an individual break pad. Now, individual break pad lasts for 7,000 miles, right? So how do we do that? Right? Then actually, yes, we need to check we can use the z value. Okay, understand this, how to do it. Okay, so first we need to find the z value. Okay, z equal, we know this is 35,700, right? Then mu, what is the mu here? 38,000 divided by 5,000. Okay, 7, right? So then this is negative 0.46, right? So now how do we know it is usual or unusual? So this is the theory behind this. So you know, actually this is standard normal distribution. So this should be 0, and you know sigma equal 1, right? So this is the sigma, this is a negative sigma, this is positive sigma, and this is negative 2 sigma, and this is 2 sigma. Actually here, you know, according to the 68, 95, 99.7 theorem, could you remember? So according to that, here in this area we should have 95%. So this sigma equal 1 is standard normal, therefore this should be negative 2 and this is 2. Yes, anything in between z value negative 2 to positive 2 are usual. You see negative 0.46 should be somewhere here, right? Negative 0.46, because this is negative 1, right? Okay, understood that? So therefore, yes, negative 0.46 is in between negative 2 and positive 2, therefore it is usual. Okay, since z score is between negative 2 and positive 2, it is usual value. It is usual value, right? It is usual value, right? So then therefore you can say it is usual to have an individual brake pad last for 35,700. Understood that? Yes. Okay. Right. Next, assuming the manufacturer's claim is correct, what is the probability that the mean lifespan of the sample is less than 35,000 miles? Okay. Now what is they asking? Probability of what? X less than 35,700. Is it right? Is that the one we need? Is that the one they are asking? Tell me. Yeah, I say one, say no. Really? Yes or no? Yes. No. Yes.
Isn't it the probability of the mean?
Yeah, actually understand that. They are not asking just lifespan. They are asking mean lifespan. They are asking mean lifespan. Therefore, that must be X bar. Wait. Understood that? So that's why for the test, I give the both ways, right? I give the both ways. So you need to read the problem very carefully and understand it first. But don't think always X. Now you have X bar also. Before we come to chapter 15, yes, it was X. You don't have to worry about it. Always X. But now X bar also. Therefore, make sure you read the problem very carefully, because if you use X, you get 0. It's wrong. Okay. Right. So then, How do we do this? You know, first one, we need to find the z value, right? Probability z less than 35,700 minus, actually how do we do this? Now we know mu x. Here we use mu x and sigma x, and also we know it is normal. So from this you can say x bar also normal, and mu is 38,000, but sigma is what? 5,000 divided by n. What is the n? Is 30, is square root of n, right? Is square root 30. So this is the distribution of x bar, right? And if I simplify this, x bar has normal distribution 38,000, and 5,000 divided by root 3, it is 912.9. So this one. Okay, so now we can use these values in main. Value of mu is this, mu x bar, and value of sigma x bar is this. Okay, so then we can use those values here. 38,000 divided by 912.9. Now probability z less than, so this one is negative 2.52, negative 2.52. Okay, so now go to the z table, right? Go to z table and find the probability of negative 2.52. Negative value here, negative 2.5 here, you see that negative 2.5 here and 2, okay, here 2 should be this, that is what? 0.0059. So you can say 0.0059. This is the probability of x bar less than that. So then actually you can write down as a percentage if you want. So this answer is also right. Got it? Any questions? Can I move this one back to my read? Right. So then next one. The height of American adult woman is distributed almost exactly as a normal distribution. Okay, so height, I say height is x. Okay, so x has normal distribution. Mean height is what? 63.5 inches. So 63.5, and standard deviation 2.5. 2.5 inches. Suppose we select a random sample of size 25, n equal 25 from the population of American adult women. What is the probability that the mean height of a random sample of 25? Again, they are not asking what is the probability of height. They are asking probability of mean height. Understood the difference? Yeah, if they were asking probability of height, then we know x. But they are asking mean height, therefore we know probability of x bar less than 62.5. Okay, now you know to do this one, we need convert to the z value, right? Therefore, we need the distribution of x bar. Let me write down the distribution of x bar. We know x, here actually I can write down sigma x equal 60, sorry, mean of x, I say mean of x equals 63.5, sigma of x equal 2.5. Therefore, we can write x bar distribution. X bar also has normal distribution because x has normal, and mu is here. Let me find the mu. What is the mu x bar? You know mu x bar should be the same like as mu, right? Therefore 63.5. Therefore it's go here 63.5, and sigma x bar should be sigma x divided by root 10. N equal 25 square root. So this should be 0.5. Why? 2.5 divided by 5, 0.5. Therefore this is 0.5. Now we know this. So this is the mu x bar. Yes, I wrote the top, and this is the sigma x bar. Got it? Any questions? Let me write this, convert to the z. Probability z less than, actually you know, if you think it's look hard to do the inside, so you can write down this here. Z equal, we have 62.5 minus mu x bar, that is 63.5 divided by, we know this is 0.5 sigma x bar, right? So you know this, right? Actually what is this? X bar is 62.5, this one, then mu x bar divided by sigma x bar. Okay, let's make sure that is the one we use, right? So then this is 62.5 minus 63.5 divided by 0.5 is what? Negative 0.2, negative 2, right? 62.5, 63, negative 2, right? So therefore we can say this is negative 2, right? Then z less than negative 2. Then go to a z table. Go to a z table, negative 2. Where is the negative 2? It is here, right? You see this is a negative 2.00, that is 0.0228. Therefore probability 0.0228. So this is the probability less than 62.5, or you can say 2.28%. Because sometimes, you know, I ask what is the percentage, not probability. I don't use probability. Then I ask what is the percentage. Then actually it should go with the percentage. Okay, everybody? Any questions? No. Okay, good. Any question? No. Right. What is the probability that the mean height of a random sample of 25 women is more than 64 inches? Alright, now more than, again not only height, mean height, right? So probability of mean height greater than what? 64 inches. Now you know we have this greater than part, therefore it must be it should be for this, because of this table, x bar less than 64. Therefore 1 minus probability, I write down z here. Now we need to find the z value for the 64. What is this? Mu x bar. We know mu x bar here again 63.5. 63.5 divided by sigma x bar is, you see that here again 0.5, right? 64, then at 0.5 divided by this, it is 1. So this is 1. Now we can do that. This equal, then 1 minus z less than 1 means go to the z table, 1.0, right? You can find 1.0, it is 8413. 08413. So answer is 1037 918 945 981. So this is the probability. So we can say 15.87%. That is the probability that the mean height of a random sample or 25 women is more than 64 inches. Understood that, everybody? Can I move to next? Okay, go with this. The sugar. The amount of sugar used in a gallon of high quality southern sweet tea is approximately normally distributed with a mean of 1.8 cups with a standard deviation 0.4 cups. Understood that? Right. What is the probability that a randomly selected gallon of tea will have at least 2.3 cups of sugar in it? Okay, right. So the amount of sugar, unit cups, I say X, right, used in a gallon of high quality southern sweet tea approximately normally distributed. Okay, therefore X has normal distribution, right, normally distributed with a mean 1.8 and the standard deviation is 0.4. Okay, right. So now, what is the probability that a randomly selected gallon of tea will have at least 2.3 cups of sugar in it? What they asking now? Probability of X or probability of X bar? It is X. Probability of X. Understood now? If they are asking X bar, it should be like this. What is the probability that the total amount of sugar in 10 gallons? Actually is say in the 10 gallons. I will explain that in a few minutes. Okay, it's asked in different way, but that is a mean over there. Okay, so it just asks here X. So probability at least X. What is at least mean? It is less than or greater than? At least, right? Greater than or equal to 2.3. At least 2.3 cups. Understood that? At least. Got it? Good. Okay. So this one. At least in that, right? Yeah. So then how do we do that? This equal 1 minus probability X less than or equal 2.3. Then 1 minus probability Z less than or equal. Okay, how do we find this one? Z equal 2.3 minus 1.8 divided by 0.4. You got it? Because here we don't need to divide because this is just X. So this answer is what? 0.4. Is it right? Check it. 2.3 minus 1.8 divided by 0.4. It is 1.25, right? 1.25. Is it right? 1.25, right? So then 1.25. Right. Then actually go to the Z table. So I am not going to show you now because you know now how to do that because I need to explain more problems. That's I tried. So that is what is that? 1.25. Let me go anyway. This is 1.25, 1.2 here, and 5 should be this, right? Then 0.8944. Is it right? Check it. 0.8944. So this equal 10 power 6, 945, 990, 981. 0.1056. So I think that's right. So percentage you can leave 10.56%. Understood that? Right. Next one is B part. Read the problem. What is the probability that the total amount of sugar in 10 gallons of tea will be at least 23 cups? At least 23 cups. Okay, now they are asking 10 gallons of tea. Right? 10 gallons of tea. It means not just 10 gallons. Then if they are asking 10 gallons, then that means we need average. Okay, so 23 for the 10 gallons, so therefore we need to find the x bar equal 23 for the total and divided by 10, because 10 gallons, that is 2.3. That is 2.3. Okay, that's they're asking. Now we can write will be at least this one, right? Therefore we can write down probability x bar greater than or equal 2.3. You understood that? Very good. Yeah. Right. Now we need the distribution for the x bar. Okay. We know x was normal distribution. If you go back, it is a normal distribution, right? Here 1.8 and 0.4. So 1.8 comma 0.4. This, right? So then how do we find x bar distribution? We know it is also normal and mean is the same, but this one should be what? Sigma x bar should be sigma mean 0.4 divided by square root of 10. Understood that? Sigma x bar is 0.4 divided by square root of 10. That is 0.1265. 0.1265. Right. Therefore, I can write down 0.12. You can round this one 127. Okay. But at least try to keep 3 for the 3 decimals. So it's good. Okay. So then what we do, I can write down this one 1 minus probability x bar. I will make it now z less than equal 2.3 minus 1.8 divided by 0.12. I write down here 1265. Okay, it doesn't matter. You can use this, but I write down this 1.1265. Then this 1 minus probability z less than or equal, this one is 3.95. Now can you go to the table and check the 3.95? Can we check 3.95 in the table? 3.4 and this is 9. So we can go maximum 3.49. Right? We cannot use the table for greater than 3.49. Any number greater than 3.49. Understood that? Now, what is this value? 0.9998. So any value greater than 3.49 for the test, you can use 1. Understood that? It is a 1 always. But it is not 1 exact value, right? We can use some software to find exact value. But you don't know how to use the software, you don't know, we don't have that facilities here for the test. Therefore, just use 1. Understood that? But any number negative less than 3.49, what do you use? 0. Okay? Because if you go to negative, you see that is 0.000 something. Yeah. So therefore, you can use that. Okay? Here you see that 0.000 0.02. So after that you can use 0. Okay, for this one I use 1 here, but not exactly it is 1 actually, but this is, you can say 0, that is approximately 0. It's 0 probability. That means x bar greater than or equal to 2.3 is 0, right? Understood that? Any questions? We have 3 minutes, so let me go quick. Actually, that's why I write this one. I understood I need to explain more problems. So if I work with you, sometimes it takes time. But let me go with quick this one, okay? So you can understand it. The scores of students on the ACT exam in a recent year had a normal distribution with mean this and standard and variance is this. Oh, you see that, okay? Then can we write down X is the ACT score, right? Scores of student on ACT. I say X. So X has normal distribution, mu equal 20.4, and can I write down 3364? Yes or no? It is not. Why? It is variance. You see that test. Could you remember? Most of you didn't do that. Okay. It is a variance. That's why please read the problem very carefully. It is variance. I know you know some of you know that, but you don't get it because we always use a standard deviation. I know that. That's I do that. So that is right. Because otherwise, how can I make it different? I cannot do anything. The same thing. I give the same, maybe only different is information. Okay. So anyway, so we can write down this one. We need the what? We need the square root of this. That is the standard deviation. That is what is that? ACT. What is the square root of 3? What is that? 5.8. Okay. Right. Go ahead with that. 5.8. It is 5.8. Yeah. So then asking, thank you. What is the probability that a randomly chosen student score 24 or higher on the ACT? Right. They are asking just score. Therefore, X greater than or equal 24. Let me finish this one quick. So 1 minus probability X less than or equal 24. We need to convert this to the Z now. Probability Z less than equal 24 minus 20.4 divided by 5.8. Okay. So then 1 minus probability Z less than or equal 0.62 or 7. If you go to the Z table, that should be 7324. Therefore, final answer is 2676. Please understand. And okay, this. So give me actually couple of minutes. I need to just quick explanation. Explain this one. Okay. Then this asking what is the mean and standard deviation of average ACT. So then asking mu x bar. So you know that is the same thing for the mu, and asking sigma x bar. So this is, you know, sigma x 5.8 divided by 30 student is square root of 30. So this answer is 1.059. Okay, 1.059. Understood that? So then actually next one I am not going to do it, but what you have to do, find the x bar less than equal 24. This answer should be 0.003. 0.003, okay? 0.003.